Hello students, welcome to Sri Jendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4 of a unit Gravitation. So let's begin with today's class. In today's session we are going to discuss about the gravitational potential energy. So let's begin. The work done to displace a body from infinity to a point in the gravitational field against the gravitational field direction is called as the gravitational potential energy, and we are going to denote it by the u. So now let's just derive the relation for the gravitational potential energy. Let's understood that this is one of the object, and this object is having mass m, and another object having mass small m has been placed over here. And let's suppose the distance between this object O, that is having a mass capital M, and a distance at a small m, they have been displaced by the distance x. So let's look at this. It's a consider that a body of mass m is placed at a distance of x from the center of mass m, and the radius of this is capital R. So if I understand what would be the gravitational force of attraction between them, this will be equals to F is equals to this mass multiplied by this mass divided by square of the distance between these two. This F is equals to gmm by x square. So if I make a dw amount of work done to move the body from A to B, this object was here, I'm going to shift this body from A to B by an amount of distance dx against the gravitational force, then I can write it's a dw is equals to f dx, and this force could be written as it's a gmm by x square into dx. So now the total work done in bringing the body from infinity to the point P is given by, let's have a look, it's a dw that A is equals to f into dx, and this f was gmm by x square into dx. This is equals to dw. Let's just integrate this. This will give me the work done. When from where to where integrate is, it's from infinite to the point P. So this is from infinite to location, let's say R. This is equals to gmm integration of x to the power minus of 2 dx from infinite to point P, which is at distance of R. So let me just write it as an R. So this will be equals to, this is work done is equals to g m m into bracket x to the power minus 2, which will be minus 2 plus 1 divide by minus 2 plus 1. So this is equals to minus 2 plus 1 from infinite to location R. This is equals to gmm into bracket minus 2 plus 1, this is equals to minus 1, x to the power minus 2 plus 1, this is equals to x to the power minus of 1, infinite to R. This will be minus of gmm into bracket x to the power minus of 1, this is 1 by x infinite to R. So this could be written as this work done is equals to minus of gmm into bracket 1 by R minus of 1 by infinite. I hope this is clear. So this could be written as, this is gmm into bracket 1 by infinite minus 1 by R. This work done can be written as minus of delta U. It's a negative of change in potential energy. When I write minus of delta U, that means minus of U final minus of U initial. This is equals to gmm into bracket 1 by infinite minus 1 by R. So this could be written as ui minus of ui minus of uf equals to gmm into bracket 1 by infinite minus 1 by R. I hope this is clear. So when we define a potential energy, when we define a potential energy, we make a reference. So for reference, we choose infinite as a reference. So potential energy at infinite is 0. So this is the initial potential energy, that is 0. So what I can have is the U F is equals to minus of G M M divided by R. This minus sign is representing that force of attraction. When you want to represent a force of attraction, negative would be always there. So this is final potential energy, but now as initial potential energy is 0, so now no need to write down the final potential energy or initial potential energy. So this could be written as U potential energy, or I should say gravitational potential energy of the system. It's a minus of G M M by R, where M, it's a mass of the first object, small m, it's a mass of second object, R is the separation between this two masses, and we can write minus of gmm by r, because I can write this because potential energy at infinite is assumed to be 0. So this has been defined. This has been defined that potential energy at the infinite will be 0. And as I have defined this, I can write this potential energy. This potential energy would be equals to always minus of G into M1 into M2 divided by R, where R is the separation between these two masses. So this is this I can say master formula for us to calculate the potential energy. And now we are going to use this formula to define the potential energy of the objects and potential energy of the systems as well. So let's have a look. Let's suppose we have one of the object having mass m, another object having mass m2, and the separation between these two is the r. So if I want to define the potential energy, I will write it's a minus of G into m1 into m2 divided by r. I hope this is clear. Is it clear? Is it? So this is the potential energy of this two system. Is it clear? Any doubts up till now? Is there anything? Is there? No? Great. Let's work for the next. The next question says that let's suppose we have three masses. It's an m1, it's an m2, it's an m3. The distance between these two is the r1. The distance between these two is the r2. The question was same here. It was the find gravitational potential energy. Even here it's a find gravitational potential energy. So how will you do this? What I am having is that I am having the relation of only two masses, but this is the relation containing three masses, m1, m2 and m3. So how will I do this? So what I'm supposed to do is that I'm going to form a pair. Please have a look very clearly once we are going to discuss it, and then no need to discuss it for the next time. So please make it clear for the very first time. This is the first object, this is the second object, this is the third object. Make a pair of two objects. So it would be a 1 comma 2. Next it's a 1 comma 3. So all the options of 1 has been over, then only pick 2 as an option. I hope this is clear. First begin with the 1. I have to chosen 1 comma 2 and 1 comma 3. Then it's a 2 comma 1, it's a 2 comma 2, It's a 2 comma 3, such as 1 comma 1 would be the option over here. Next it would be a 3 comma 1, 3 comma 2, and 3 comma 3. A one thing is you cannot have minus of g into m1 into m1 divided by r, because two different masses would be there. So the pair that relates 1 1, 2 2, and 3 3 cannot form a potential energy for us. Is it clear up till now? First, is it clear? Is it? Are you sure? So this could not form a proper potential energy. So these are not the valid options. Now let's look at the next options. We have here 1 comma 2 option, which is minus of g into m1 m2 divided by r. Here we are having a 2 comma 1 option. If I write this, it's a minus of g m1 m2 divided by r. If it is 2 comma 1, it's a minus of g m2 m1 divided by r. Sorry. So these two are the same option. And when these two are the same option, need to you need to cancel any one of them. So let's cancel it. So repetition of pair should not be there. When I say repetition of pair, I must understand 1 comma 2 and 2 comma 1 is the repetition. Same way here, 1 comma 3 and 3 comma 1 is the repetition, so cancel it. Here 2 comma 3 and 3 comma 2, it's a repetition, so cancel this. I hope this is clear. So I have been left with only this pairs. I am having only this, that I'm having 1 comma 2, I'm having 1 comma 3, and I'm having 2 comma 3. This 1 1 2 2 and 3 3 has been gone. Why? Because object cannot have a potential energy with its own self, and the remaining pairs has been cancelled. Why? Because it is creating a duplication of pairs. I hope this is clear. So now what I need to do is I need to just write down the potential energy, what it would be. Let's redraw it. It's an m1, next it's the m2, next it is the m3. This separation is r1, and this separation is r2. Now now you are having the pairs. It's is first, second, and third. So this would be a 1 comma 2, 1 comma 3. Next it's a 2 comma 3. The other pairs have been cancelled out. So now let's write down the potential energy of the system, which could be 1 comma 2. It's a first object, it's a second object. It's a minus of g m1 m2 divide by separation between these two objects. This is r1. Now 1 comma 3, it's a minus of g into m1 m3 divide by 1 2 3, it's an r1 plus r2. Next it's a 2 comma 3, this is minus of g into m2 m3 divided by r2. So this is the total potential energy. This is the total potential energy of the system. I hope you got this. Did you? Did you get this? Any doubts? Is there anything? Do you understand this? Are you sure? So ready for the next question? Let's have a look. We have three masses on an equilateral triangle at their vertices. Something like this, that this is m, this is m, this is m. The question is, find gravitational potential energy of the system. Dimensions of the triangle is a. It's an a. It's an a. So it is obvious that remaining portion is of a. So this is the situation. How will you do this? So let's give them a number. It's a first, it's a 2, it's a 3. Now it's a mechanical process, that first give them a number. It's a first task. Second task, write down their pairs. It's a 1 comma 2, 1 comma 3, and 2 comma 3. Now write down the potential energy. It's a U is equals to 1 comma 2 this and this. It's a minus of G into M square divided by A. 1 comma 3, it's again minus of G into M square divided by A. 2 comma 3, this is 2, this is 3, it's a minus of G M square by A. So this will be the minus of 3 into G M square by A joule. This is the potential energy of the system. I hope you got this. Have you got this? Are you sure? Let's work for the next question. Do it quickly. It's a find gravitational potential energy of the system. Now it's a square having masses on their vertices. It's an M, M, M. The dimensions of the square, it's an A by A. You need to find out the gravitational potential energy of the system. How will you do this? It is as simple as this. It's a first, second, third, and fourth. 1, 2, 3, 4. So when I write this, it's 1, 2, 3, 4. Let's just do this. First task is to form a pair of this. First task is to form a pair of this, and if I want to make a pair, I would like it's a 1 comma 2, it's a 1 comma 3, it's a 1 comma 4. Anything has been left? No. Next 2 comma 1, but it's a repetition, so 2 comma 3, yes. 2 comma 4, yes. Another a 2 comma 1 is there. 2 comma 2 could not be exist. 2 comma 3 and 2 comma 4 has been written. Next 3 comma 1, but it is already here. 3 comma 2, it is already here. 3 comma 3 does not exist, and 3 comma 4. I hope this is clear. So total 6 pairs are there. Total 6 pairs are there, and let's write it down the quickly. The relations that U is equals to 1 comma 2, it's a minus of G into M square divided by A. Then 1 comma 3, this is M, this is M, but the distance is not A. The distance would be, this is A, this is A, the distance would be equals to root of 2A. So this is equals to minus of G M square divided by root of 2A. 1 comma 4, this is 1, this is 4, their separation is A. So this is equals to minus of G M square by A. Next 2 comma 3, again minus of G M square by A. Next 2 comma 4, again they are the diagonals, so it's again minus of G into M square divided by root 2A. And 3 comma 4, that is again minus of G M square by A. So I have 4 pairs which is having Gm square by A, and 2 pairs having divided by root 2A. So this could be written as minus of 4 into Gm square by A minus of 2 into Gm square divided by root 2A. So this is equals to, this is minus of 4 into Gm square by A. This is minus 2, this is root 2, so this is minus of root 2 Gm square divided by A. This is the potential energy of the system. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Great. Now one more thing, and very important, that how could I come to know that how many pairs are there? That by trial or error, when you are defining these pairs, how will you come to know that yes, you have done it correctly, or no, you probably made a mistake? So the total number of pairs, total number of pairs, n will be equals to n into n minus 1 by 2, where n is the total number of masses and n number of pairs to be formed. I hope this is clear. So if I am having an 4 masses, if I am having a 4 masses, this is 4 3s are 12 by 2, it's a 6. So look at this situation. We have four masses, one, two, three, four. We have four. We have six pairs. One, two, three, four, five, six. Got it. I hope this is clear. If you are having a three masses, then this could be equals to 3 into 2 divided by 2. This 2 has gone, and this we are having a three pairs. Look at this. Three masses. It's one, two, three. It's the first, second, and third. Yes. So this can be this can work as a lock and key, that when and when, because at the time of the examination, due to hurry of something, or probably due to in a status of mind will be a heavily stressed, we forget to write something, and if we forget to write something, that means we are missing that pair, and we will probably land to the incorrect answer. So this is the safe option. Always check it that I have made this much pairs. Was it sufficient? If yes, then go further. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you? Are you sure? Great. Now, let's work for the next pattern of question. The question says that, let's suppose understood that the situation is initially two masses, or I should say two identical masses, were separated by distance a. Now what I want that this mass m and this mass m will be separated by distance 2a. So this is the initial system. This is the initial system, and this is the final system. So initially it was separated, they were separated by distance a. Finally they were separated by distance 2a. The question is, find out work done required to separate masses by distance 2a. This is the situation that you need to find out the work done required. You need to find out the work done required to separate the masses, to separate this masses by distance of 2a. Now how will you do this? What do you think? How this is supposed to be performed? How could I? So what I need to do is always do one thing, that we understand that work done is equals to delta u, and for delta u to perform, you need to write down it's a uf minus ui. So follow this guide step by step, and you will easily calculate this. So first write down ui. In this case it's a minus of gm square divided by a. Next calculate uf. It's a final potential energy, that would be equals to minus of gm square divided by 2a. Now find out work done, which is equals to delta u, that is equals to minus of gm square by 2a, minus of gm square by a. So this could be written as minus of gm square by 2a. It's a minus minus plus gm square by a. So this is equals to minus of gm square by 2a plus 2gm square by 2a. This is plus 2gm square, this is minus gm square, it's a plus gm square by 2a. This is the work done. Now the thing is this work done is being positive, but is it a work done by external force, or is it a work done by internal force? How will I do it now? And what would be the sign if they ask that find out the work done by external force, or they say find out the work done by internal force? So what I understand is, please listen this very carefully and have a focus on this. Once it has been done, no need to revise this. So the situation is that all the forces that acts by nature are considered as internal forces. So all those forces that acts by the nature are considered as the internal forces. You do not need to apply a gravitational force. A nature itself will act on it. Yes. So the force of attraction the force of attraction will be internal force, and force which acts the force which acts in the opposite direction to the direction of motion to the direction of motion is external force. I hope this is clear. That please do this in mind, that all the forces that acts by the nature are considered as the internal forces. And in this case we are having an only gravitational force. So gravitational force is always attractive in nature, so the force of attraction will be considered as an internal force, and the force which is acting in the opposite direction to the direction of attraction, that will be treated as the external force. I hope this is clear. Is it clear up till now? Is it clear up till now? Are you sure? Are you sure? Great. So now let's understood the situation what we were having. The situation is something like this, that we have two masses that were separated by distance a, and now we have their separation is 2a. This is the initial system, this is the final system. So if they want work done by internal force, then what you need to do is first write down your work done answer. It's a g m square by 2a. Now take a decision of whether it would be a positive or whether it would be a negative. Now you have studied the work done, you must understand that what is negative work done, what is positive work done. A positive work done is if force is applied and displacement is in the same direction as the direction of force, then it is a positive work done. If it is not the case, or if reverse is the case, then it's a negative work done. So in this case, a force of gravitation acts in this direction. It's a force of gravity because it will always try to attract. But here a displacement is in this direction. That is only the case because initially separation is a, now separation is 2a. So work done by internal force, it's a negative one. It's a work done is equals to, or work done by internal forces is work done is equals to minus of gm square by 2a. Now what about the work done by external force? What about the work done by external force? How will I do this? It's a work done by external force. So to find it out the work done by external force, let's understand again this situation. The external force must act in the opposite direction to the direction of force of gravitation. Is it clear? Yes. So F external is acting in this direction, displacement is in this direction. When both are in the same direction, work done due to external force. Again, the magnitude wise it would be the same. It's a gm square by 2. It is only the positive work done. I hope this is clear. Is it clear? Is it clear? So if I write a step by step guide, then at the first step you need to calculate initial potential energy. At a second step you need to calculate the final potential energy. On a third step you need to find out the work done. You can do delta U. Choose anything, either you choose UF minus UI or you choose a UI minus UF, doesn't make any difference. When you need to decide a sign of work done. So this is the last and the fourth step, that at the end you are going to decide, at the end of the day you are going to decide the sign of a work done, that whether it is a positive work done or whether it would be a negative work done. That is what we need to decide. I hope this is clear. Yes, always apply a mind while you are going to decide a sign of work done. I hope this is clear. Is it clear? Completely. So let's extend this question in a similar fashion. Let's understood that this is M, this was M, and their initial separation were A. Now let's suppose their separation has been reduced by half of the amount and now their separation is A by 2. So again the question remains the same, that find out work done required. So what you need to do is that you need to find out the initial potential energy. This is UI, which is equals to minus of gm square by A. You need to find out final potential energy, which is equals to minus of gm square into A by 2, which should be is equals to minus of 2gm square by A. Next, find out the delta U, which is, let's say, UF minus UI, which is equals to it's a minus of 2gm square by A. Now it's a minus minus plus gm square by A. So this will be equals to, this delta U would be equals to, this is minus, this is plus, so this is minus of gm square by A, which is equals to work done. So this is work done minus of gm square by A. Now let's take the decision that what is the work done by internal forces, whether it is positive or negative. So a gravitational force which we consider as an internal force is acting in this direction. Even the displacement of particle is in this direction. How could I come to know? Because initially the separation was A, now separation is A by 2. So this is work done due to internal, is in this situation it's a positive, it's a plus gm square by A. And work done due to external, what would be its direction? If gravitational force is acting in this direction, the external force must be acting in this direction. So external force and displacement, they are aligned at 180 degree to each other. That means work done due to external force, it's a minus of gm square by A. I hope this is clear. So this is very simple kind of questions. This is the questions which I say it's all questions based on the reconfiguration of the masses, or I should say it's a restructuring of the system. What you are supposed to do is that separation is this, make this to new one, separation is this, make this to this one, and all the things will be done. I hope this is clear. Is it clear? Is it clear? So do you understand this? Have you? Have you understood this? Can you do this kind of questions? Let's do it quickly. The question says that find out work done required. Also find out. Also find out work done by internal and external force. So what is to be done? Initially the system looks like this. This was M, this was M, this was M. Their separations were A, and finally finally the system will look like this. This is 2a, this is 2a. So the masses absolutely remain the same, and this was initial system and this was final system. So you need to do this. How will you do this? You need to find out the work done required. So what I need to do is I need to form a initial potential energy, what it would be. So let's give them a number. It's a first, it's a second, it's a third. So this ui can create a form, ui can create a pair having mass of it's a 1 comma 2, 1 comma 3, and 2 comma 3. So this all masses are same, gmm by a, gmm by a. So this is minus of gm square by a multiplied by 3. Yes, first, second, and third. Now same way, find out the final potential energy of the system. What it would be? It would be a minus of 3 gm square by 2a. So I am having the initial potential energy of the system, I am having the final potential energy of the system. Let's find out the work done, which is equals to delta u, which is equals to u final minus of u initial. This u final would be minus of 3gm square by 2a. This minus minus plus, it's a 3gm square by a. This is equals to minus of 3gm square by 2a plus 3 2s are 6 gm square by 2a. This is 2a, this is 2a, so I can, this is plus 6, this is minus 3. I have been left with the plus 3 gm square divide by 2a. This is the work done. It's a plus 3 gm square, plus 3 gm square divided by 2 into a. That's it. Does it clear? Is it? Are you sure? Are you sure? Great. Now let's discuss what is the work done due to internal force and what is the work done due to external force. So let's choose any one of the option. This m and this m will attract each other. This is force of gravitation. But initially their separation was a and finally their separation is 2a. So they have displaced in the opposite direction. This is x. So what I can write is the work done due to internal forces is it's a 3gm square by 2a, but in negative. I hope this is clear. Yes, because force of gravity and force of direction of displacement are aligned at 180 degree, 180, it's 180 degree to each other. Now if force of gravity is in this direction, force, I should say external force in this direction, and direction of the external force and direction of the displacement is same. So I should say it's a work done due to due to external force. Work done due to external forces could be written as work done is equals to plus 3 gm square divided by 2a. This is in positive. So this is work done due to external forces, that could be given me as plus 3 gm square by 2a. So you don't bother about that whether I should go for the uf minus ui or whether I should go for the ui minus uf. No, it doesn't make any sense. Go with anyone which you want and then decide the directions. If work done is negative, then your final answer should be in negative. And if you want the work done due to external force and let's say it is positive, then your final answer should be a positive one. It is as simple as that. I hope this is clear. Is it clear? Is it? Are you sure? Ready for the next question? Are you? Let's have a look. The question says find out work done required. Now what is the system? The system is something like this, that initially it's a square basically, and initially it is having a mass m and mass m, and the dimensions of the square is a by a, and here no mass is there, but one of the mass is there which is at infinite. One of the mass is there which is at infinite. Now this is the initial system. Now for the final system, what do you want? You want that this system will look like this, that this is the mass m, and this is mass m, this is mass m, and this should be mass m. So what do you want? You want that you are going to bring this mass m from infinite to that location, and it has been placed over here. This is the final situation. So how will you do this? How will you do this? And what can be done? What is to be done? So what I understand is, let's give them a number and we will be having certain hints. First, second, third. Initially it is having only three bodies because this was at infinite, and energy, or I should say potential energy at infinite, is considered as a zero. So these three masses were there initially. Now afterwards it would be having a four masses: first, second, third, and fourth. So afterwards it is having a four masses. So what I need to do is first create a pairs, and let's just check it out that what it can give me. So if I create a pair for this, it's a 1 comma 2, it's a 1 comma 3, and it's a 2 comma 3. Now I am having a pairs of, it's a 1 comma 2, 1 comma 3, 1 comma 4, it's a 2 comma 3, 2 comma 4, and 3 comma 4. So these are the pair for the initial configuration. These are the pair for the final configuration. Now always take care that your mass sequence should be similar. This is first, second, third. This must be the first, second, third. It is having its own benefit. I will let you know. So this is first, second, third, and fourth. I hope this is clear. Now what you are supposed to do is, now in the next step you are going to write down this work done is equals to uf minus ui. That means whatever you have pairs written over here, you are just going to use it, and you are going to subtract this. So not to write potential energy, directly subtract the pairs. Do you understand what I mean? Look at this. The separation of this is a by a. When you write 1 comma 2, what you are supposed to write? It's a g m square by a. When you are supposed to write it here 1 comma 2, what you are supposed to write? It's a g, that means minus of gm square by a. When this is minus of gm square by a, this is minus of gm square by a. When I am subtracting this from this, definitely this is going to be 0. So not to write that pairs, I mean it to directly subtract it with a pairs. So when I subtract it with pairs, I will be, it's a 1 comma 2 has gone, 1 comma 2 has gone, 1 comma 3 has gone, 1 comma 3 has gone, 2 comma 3 has gone, 2 comma 3 has gone. So I have been left with this pairs. That is what required. So this is work done is equals to uf minus ui, and this pairs remaining, it's a 1 comma 2, it's a 2 comma 4, and 3 comma 4. So the situation, the I'm drawing only the final situation because only that is required. Masses are there, it's an m m m m, and the numberings of the masses were first, second, third, and the fourth. So when I write this, it's a final potential energy minus of initial potential energy, and while writing this, it's a 1 comma 4. So this is equals to minus of g m square by a. It's a 2 comma 4. This is equals to minus of g m square divided by root of 2a. It's a 3 comma 4. So this is equals to minus of g m square by a. This minus gm square by a minus gm square by a, this is equals to minus of 2gm square by a minus of gm square by root of 2a. So if I take a minus as a constant, or yes, let's look at this. It's a minus of gm square by a into bracket, this is plus 2 plus 1 by root of 2. It's a 2 plus 1 by root 2 minus of gm square by a as a constant, and this is work done. I hope this is clear. Is it clear? Is it is it clear? Now let's decide that what would be the work done due to internal force, or how it would be, whether it is a positive or it is a negative. How could I check it out? So what I understand is initially this mass is at infinite. So this is very far away, and it is the force of all this which brings him from infinite to this location. I hope this is clear. So a force of gravity may be acting like this. I could say this because it's a force of gravitation only. That is what I want to show you. And even the force of displacement isn't like this. So work done in this situation, work done due to internal force, work done due to internal force is positive. If force of gravitation is in this direction, then force of external force in this direction, and that's why work done due to due to external force is negative. Are you clear with this? Are you clear with this? Are you sure? Any doubts? Is there anything? No? Good. Questionnaire has asked that. Find out. Work done required. Now, for what? Let's have a look. It's a square system, and initially these four masses are there. It's an M, and M. It's an initial system, and the fifth mass that we call a capital M, it is at infinite. Now the situation will come that that this four masses would be at the same location. It's an M, but this fifth one should be at the center of the square. So the dimension of the square, it's an A by A. You need to perform a work done for this. How will you do this? How you are supposed to? What shall we do? So what I understand is that, let's say this is first, this is second, this is third, this is fourth. Yes, let's make a pair, and looks like what happens. It's a 1 comma 2, 1 comma 3, 1 comma 4. It's a 2 comma 3, 2 comma 4, and 3 comma 4. I hope this is clear. Now again a same number would be there. It's a 1 2 3 4, and this one will behave as a fifth one. So this is 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5. Yes, it's a even 1 comma 5. It's a 2 comma 3, 2 comma 4, 2 comma 5. It's a 3 comma 4, 3 comma 5, and one new pair. It's a 4 comma 5. I hope this is clear. So what I'm supposed to do is I'm going to write this as a UI, this as a UF, and I'm going to subtracting it. It's a, let's say, delta U, that we call as an UF minus UI, that is the final potential energy minus initial potential energy. When I'm going to subtract it, I'm going to nullify this pairs: 1 2, 1 3, 1 4, 2 3, 2 4, 3 4. So I have been left with only this four pairs. 1 comma 5, 2 comma 5, 3 comma 5 and 4 comma 5. So if I have been left with this only, the situation will be equals to it's a minus of G into capital M into small m divide by the separation. The separation between these two. What is it? Look at this. It's an A, it's an S. This complete is root 2A. Now this half of the distance, it's a root 2A divided by 2, which is A by root 2. So this is A by root 2, and such is the 5 pairs. It's a first, such is the 4 pairs, sorry. Second, third and fourth. So multiplied by 4. So let me rearrange this. It's a minus of 4 root 2 GMM divided by A. I hope this is clear. This is the work done required. This is the work done required. That's it. You did it. Great job. I hope this is clear. Is it clear? Is it any doubts? Anything? Is there anything? Are you sure? Are you? Great. Let's work for the next question. They said that initially the system is looking like this, that we have first, second and third. It's an M. This is 2M. It's an M. The separation between this two is the A. The separation between this two is the A. This was the initial system. What I want next, it is the I'm going to displace this 2M perpendicularly. So this will be again A, 2A, sorry. And this distance is A. So the question is, find out work done required. So what I'm supposed to do is that, let me give the number. It's a 1 comma 2 comma 3. So the pairs will be 1 comma 2, 1 comma 3 and 2 comma 3. So this is initial potential energy, that will be equals to 1 comma 2. It's a minus of G into M into 2M by A. 1 comma 3, it's a minus of G into M, it's an M square, divide by the separation between 1 and 3, it's a 2A. Next, it's a 2 comma 3, it's again minus of G into M into 2M, divide by 2 comma 3, it's an A. I hope this is clear. Is it? Is it clear? Okay, great. Now let's find it out, the final potential energy. This is M, this is M. Their separation is 2A and this is A. So this separation, this will be root of, it's a 4A square plus A square, which is equals to root of 5A. I hope this is clear. So finally pairs will remain the same, but their separation would be the different. So let's call it, it's a 1 comma 2. This is equals to minus of U into, sorry, minus of G into M into 2M divide by root of 5A. Next, 1 comma 3, it's a minus of GM square by 2A. Next, this comma this, it's a minus of G into M into 2M divide by root of 5A. Now when I'm going to do this, it's a UF minus UI. What would be cancelled out? Look at this. This minus of GM square by 2A multiplied by, yes, this is minus of GM square by 2A, and this minus of GM square by 2A would be cancelled out, and the all remaining term would be there, because their separations were different. So you know the rest amount of the task. I hope this is clear. Is it clear? Is it? Are you sure? So can you do this? Can you do this? Is it possible to be done by you guys? Are you sure? Are you sure? Let's discuss about the energy conservation. When we said energy conservation, when we said energy conservation, we consider that it is transfer of energy from one form to another, but total energy will remain conserved. Yes, this is not the statement, but this is the idea behind the energy conservation. So when and when we conserve the energy, when and when we say it, that energy would be conserved, that we always understand that we are going to transfer energy from one form to another. But total energy, when I say total energy, let's talk about the system. It's the total energy of the system will always remains conserved. So if initial total energy is 100, it is going to be there of 100 only. I hope this is clear. Is it clear? Is it any doubts up till now? Is there anything? Are you sure? Are you sure? Great. So let's look at this with the help of questions. Let's suppose Earth is there, and this is the center of the Earth. This is the radius, it's an RE. Mass of the Earth, it's an ME. Now from this surface, a small object having mass m has been thrown in upward direction with velocity u. The question asks that find out maximum height that can be covered by object having mass m. We need to find out the maximum height that can be covered by object having mass m. So what I should do? What do you think? So what I'm supposed to thinking is that let's suppose that has been thrown from this. Let's say it is going to be reach over here. It is going to be reach over here, and this is probably the maximum height. So let's call it as an h max. But when I call it as an h max, I must understand that at this point its velocity would be zero. That's why only this is could be considered as h max because its velocity would be zero. Now what do you need to do? You don't need to do anything new. You need to perform only energy conservation. This is the first location, this is the second location. So we have done this in previously so many times. One more time here, it's a total energy of 1 is equals to total energy of 2. When I say total energy, I mean it's a potential energy 1 plus kinetic energy 1. This is equals to potential energy 2 plus kinetic energy 2. Potential energy 1 at this point. Do not make a mistake by considering that this is the reference. I am going to write this as a 0. No, we are going to write it in an absolute manner. It's minus of g into me into m divided by re plus half m u square. This is equals to potential energy 2. This is equals to minus of g me m upon re plus h max plus kinetic energy 2. It's a 0. That's it. So what I can write is it's an half mu square, that is equals to it's a minus of g mem upon re plus h max plus it's a g me m divided by re. So if you want to solve this a little, you can you can make this cancel. It's this. So this could be written as again GME as a common. This is equals to minus of 1 by RE plus H max minus 1 by RE. I hope this is clear. This is equals to half into U square. So from this you can have this and get the answer done. I hope this is clear. Is it clear? Is it? Are you sure? So can we do this? Ready for the next question? Can you do this? Great. Now let's look at the second question. Let's say this is surface of the earth, and when I say this is surface of the earth, this is its center, this is the radius RE, this is its mass which we call as an ME. Here the object was at rest, it is going to be free fall and it is going to be dropped from here. Now when this object reaches on the surface of the ground, you need to find out the velocity. Question says find velocity of an object when it hits the surface of the earth. Let's call this distance as an h. So how will I do this, or what should I do? Same thing, it's a first, this is second. It's a total energy of first object should be equals to total energy of second object. When I say total energy of first is equals to total energy of second, I mean it's a minus of total energy of one. At this position it's a minus of GMEM upon R plus H plus, here kinetic energy is 0, equals to total energy, it's on this point it's a minus of GMEM divided by RE plus half mv square. So this half mv square should be equals to, it's a minus of GMEM upon RE plus H plus GMEM divided by RE. I hope this is clear. So this mass, this mass, this mass, this has been removed. This could be written as v square by 2, that is equals to GMERE minus of GME divided by RE plus H. Yes, so this v square could be written as, this is equals to 2GME by RE minus 2GME by RE plus H. This will be the answer. I hope this is clear. Is it? What was your answer? Was it same? Was it? Are you sure? Have you got the same answer? Have you? Are you sure? Are you correct? So now let's look for the another question. Let's suppose this is one of the planet. Mass is m, radius is r. One of the object is been thrown in this direction with speed u, and when it reaches here, when I say it reaches here, this is 4r, 4 times the radius of this planet. Let's say this as a location 2, this as a location 1. They want that find out velocity of object 2. Find out velocity of object, I should say, at position 2. At position 2. So at this point I want the velocity of an object. How will I do this? Look at this. This planet is there, and on this planet a ball is there. A ball is having a small mass m, and it has been thrown in this direction with speed u. What you need to do, you need to find out the velocity at point 2. How will I do this? So again, we have marked the location. It's a 1 and 2. What I'm supposed to do is the total energy at first should be equals to total energy at second. Now, what would be the total energy as first? Does it have potential energy? We should say yes. It's a minus of G M M divided by R plus kinetic energy. It's a half mu square, that is equals to total energy at 2. Energy at 2, that means when they are separated by a distance of 4r. This is minus of GMM by 4r plus half mv square. I hope this is clear. So when you find out, or when you want to find out the velocity at this location, yes, this all has gone, and you have been left with the minus of gm by r plus u square by 2, that is equals to minus of g into m by 4r plus v square by 2. So this could be written as, this is equals to v square minus of u square by 2, that should be is equals to gm by 4r minus 4gm by 4r. I hope this is clear. This term has been shifted to this, and this has been shifted to this. So this minus of gm by 4r will become a plus gm by 4r. So this could be written as v square minus of u square divided by 2, that should be is equals to minus of 3gm by 4r. So this is 2 2s are. So this v square is equals to u square minus 3gm divided by 2r. This is the final velocity. If I want the velocity, let's pick this into a square root. It's a u square minus of 3gm divided by 2r whole power 1 by 2. I hope this is clear. So have you done this? Have you done this? Do you understand this? Have you? So can you write things like this? Do you understand completely even the aspect of energy conservation? Are you sure? Are you? Great. So let's just wind it up this session over here. This is all about the potential energy, or I should say gravitational potential energy. Yes, please have a practice of this kind of questions, because this kind of questions will help us not only in gravitation but even in the first unit, on the second unit of class 12. Yes, so please revise it. Please be confident while revising. Thank you. Have a good day. Take care. Bye.